Hello. So the next topic we're going to learn is piecewise functions. So piecewise functions describe a function basically by piece. That's why it's called a piecewise function. So this graph, if you're not familiar, this is f of x is absolute value of x, okay? So for example, when x is 1, y is absolute value of 1 is 1. If x is 2, y is absolute value of 2 is 2. If x is negative 1, then y is absolute value of negative 1, so it's 1. If x is negative 2, then y is absolute value of negative 2, so it's going to be 2. So as you can see, when x is 1, y is 1. When x is 2, y is 2. When x is negative 1, y is 1. When x is negative 2, y is 2. And obviously when x is 0, y is 0. Okay? So you can tell why this is an absolute value function, okay? Then it is okay to just write down f of x is absolute value of x. But imagine you want to explain this function to someone who never learned what absolute value is, okay? But let's say that person only knows what linear function is, okay? Then we can cut this graph into two pieces, specifically here, because that's where the slope changes, right? So we can make the two pieces, one is on the right and one is on the left, okay? Then from the center middle point to the right is where x is 0 to greater, right? So that portion I can name it as, so this portion I can name it as x is greater than or equal to 0, okay? Then this left half, I can call this portion as where x is less than 0. You might ask me, why do I include x is 0 on the right side, not the left hand side? Because the x is 0 should be included one of those 2 points only. And in this example, from the left side to right side, anyways, they have the same value at when x is equal to 0. So I just randomly picked the right portion. So if you want to say the opposite, let's say the left portion is x is less than or equal to 0, and the right side is x is greater than 0. For this example, there's no difference, so that is fine. Then next portion is, now we need to describe what that portion is in terms of equation, okay? So this left portion, obviously that's a linear function. And to describe a linear function, we need to find the slope and the y-intercept. So the left portion, if you see, when x increases by 1, y decreases by 1, right? So the slope is negative 1. And how about the y-intercept? So the y-intercept is where the graph intersects with the y-axis. That's gonna be at 0, right? So the slope is negative 1 and y-intercept is 0. So therefore the left portion is y is mx plus b, so negative x plus 0, so we can just say negative x. So y is negative x is the left portion of the graph. Then how about the right portion of the graph? So the right portion of the graph is, first we can find the slope. So when x increases by 1, y increases by 1. So the slope is how much did y increase over how much did x increase, right? So it's going to be 1 over 1. So the slope is 1. So the slope is 1 for the right portion. And how about the y-intercept? Again, the y-intercept is the same. It's where the graph intersects with the y-axis that's at the origin, 0, 0. So b is 0. So therefore, the equation for the right side is y is mx plus b, so m is 1, x, so 1 times x is x, and plus b is 0, so plus 0, or we can just ignore it. So the right portion is y is x. So the last part of our job is just to combine these two parts. So y is negative x and y is x. And what is the right portion again? That's where x is greater than or equal to 0, right? How about the left portion? That's where x is less than 0, right? So we can combine these two information. We can say f of x or y is x when x is greater than or equal to 0. And f of x or y is negative x when x is less than 0. So this is a way to write down the absolute value of x in piecewise way. Okay, so let's look at the next example. So in the next example, this function mainly has 3 portions. So the first portion is the red part, second portion is this blue part, and the third portion is this green part. So first, again, we just want to confirm the interval for x for each portion. Okay, for the red portion, the far left, the most left point for x is where x is -4. The most right point for x is -2. Okay, so for this red portion, x is between -2 and -4. Okay, then now let's find the interval for x in the second portion. Okay, this portion. So here x is -2, but we are not including x equals to -2 because there's an empty circle. And again, the empty circle means it's defined at exact point there. So x is not defined at -2 at that point. So we need to say x is strictly greater than -2. Okay, at that point, x is strictly greater than -2, and it goes to how much to the right? Here is 1, right? So x is strictly less than 1. So that's the interval for the second portion. And finally, the third portion here, x starts from 2 and it ends at 4, right? So the third portion is x is greater than or equal to 2 and x is less than or equal to 4. So first, we could find the intervals for each portion. Now the second part is we need to find the specific equation that describes each portion. Okay, so the red part, again, that's a linear equation, linear function. And to find the linear function, the equation, we need to find the slope. So you just pick some nice points where the graph passes through some, this cross, the corner of squares. So because that's easy to read, right? So this point looks easier to check because x is -3 and y is -1, right? And that point is where x is -2, y is 2, right? So x increased, so x increased by 1 from -3 to 2, so x increased by 1 there, and y became from -1 to 2, which is y increased by 3. So y increased by 3, x increased by 1, which means the slope is 3 over 1. So the slope is 3. Okay? Now, to find the linear equation, what do we need? We need the slope and we need the y-intercept. So in this case, it's really hard to find the y-intercept because this graph doesn't extend to y-axis. So it's not intersecting with the y-axis. So instead of using the slope and intercept form, we need to use another form of a linear equation, which is point-slope form. So if I remind you what slope-intercept form is, point-slope form is. So let's say I know the slope of the line M, okay? And also I know a point, any point on the line, okay? Any point, it doesn't matter, any point on the line. So let's say x1 and y1, so that's a point on the line, okay? Then we can write the equation of the line by y minus the y coordinate of that point, y1, equals slope times x minus the x coordinate of the point I know, x1. Then this describes the line as a linear equation. Okay? So now we are going to use this to find the equation form of the first portion. Okay? So let's go back to there. So this line obviously passes through, for example, x is -2, y is 2 point, right? So, sorry, not 2, y is 1. So this is x is -2, y is 1. So this line passes through, yeah, that's the end point, but still passes through that point. So we can use that point, okay? So the slope is 3, and the point it passes through is -2, 1. Then now, based on point-slope form, we can find the linear equation. So y minus this number 1 equals slope times x minus this number negative 2. So now let's simplify this. So y minus 1 is minus is plus, right? It's 3 times x plus 2. Now we do distribution. So y minus 1 is 3x and plus 6. Now we add 1 and add 1 both sides. Y is 3x plus 7. Okay? So we could find the first portion equation is y is 3x plus 7. So now let's find the equation for the second portion, which is going to be quite easier because the second portion, it's horizontal, right? So what does that mean? Y is 2, 2, 2, 2, 2. No matter which point you pick on the second portion, y is just 2. So y is simply just 2, okay? Let me write that down here. And finally, the third portion. So we need to do the same thing as the first portion. So first of all, we need to find the slope. So we can just use endpoints in this case, quite easy to tell. So x increased by 2, right? 2 to 4, x increased by 2. And how about y? So here y was 2. Here y became 0. So it decreased by 2, right? So y decreased by 2, x increased by 2. So the slope is negative 2 over 2, which is negative 1. So the slope is negative 1, okay? Next, we need to find the y-intercept, but again, I cannot find the y-intercept because this doesn't extend to y-axis. So instead of that, I'm going to use a point to use the point slope form again. So I'm going to use this endpoint when x is 2, y is 2, right? When x is 2, y is 2. So I'm going to use that point to describe this linear equation. So y minus this number 2 equals slope times x minus this number 2. So first I do the distribution. Y minus 2 is negative 1 times x, negative 1 times minus 2 plus 2. Now I add 2 to both sides. So y is negative x plus 2 plus 2, 4. So this is the third portion of the graph. So now we can combine all these three information together to make one piecewise function. So you can say y, or f of x, equals, so what is the first portion? 3x plus 7, right? 3x plus 7. When x is between negative 2 and negative 4 inclusive, okay? And how about the second portion? Second portion is just 2. When x is between negative 2 and 1, but not including negative 2 and 1. Finally, the third portion is this one and this one, right? So the equation is negative x plus 4, when x is between 4 and 2 inclusive. So we could find the piecewise function that describes this graph. In this case, if I talk a little bit more about characteristics. So first of all, the maximum is basically the highest point, so largest value of y that this function has. So at this point here, y is 2, right? And no other portion of the graph goes beyond that point, so the maximum is 2. Okay? The minimum is the lowest point of the graph or the function. So that's gonna be here, right? That's negative 4, 5. So that's negative 5. How about the domain? So domain is again the x values that's assigned by the function. So it starts from negative 4, goes to negative 2, goes to 1, but not including 1 because here is empty. It means this function is not defined when x is 1. So from here to here, x is from negative 4 to 1, but not including 1. And from here to here is x is 2 to 4, right? X is 2 to 4. So this is the domain of this function. And how about the range? So range is the y values that are assigned by the function. So let's check what kind of y values are assigned. So the lowest point for y is here, which was -5. So y starts from -5. And it goes up, 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 up. It looks like it's empty here. But if you go to the right portion, it's still continuing, right? Up, up, up until y is 2. So from -5 to 2 inclusive, y is defined. So the range of this function is y is between -5 and 2. Okay? And this function is positive on this portion, this portion, this portion. And this function is negative on this portion, okay? Finally, this function is increasing in this red portion, or we need to say strictly increasing, but anyways, increasing. And this green part is where this function is decreasing. Okay? So the last example here is, so this is actually, we need to figure out what this graph is again, okay? So we know that based on the shape, this is a form of absolute value of x graph, okay? So in this case, we call this y is absolute value of x as the parent function, because this is the simplest form of describing an absolute value function. So for example, when you have linear equation, linear function, the parent function is y is x, because that's the simplest form. If you have a quadratic function, I didn't teach that yet, the simplest form is y is x squared. So this is the parent function of quadratic functions. But anyways, so y is absolute value of x is the parent function. And now if you look at this graph, as you can see, the vertex, this pointy end, shifted from 0 to -1, right? So it shifted left by 1 unit. It shifted left by 1 unit, so we need to subtract 1 from x in this function, okay? So first we can tell y is absolute value of x minus 1. Okay? Sorry, x plus 1. I say add 1 and subtract 1 there, x plus 1. And then it didn't shift up or down, so we don't need to worry about what number to add to the entire function. But the second function we need to carry is the slope. Because generally when you have absolute value of x, the positive portion, the slope is 1, right? But if you look at here, from -1 to 0, when x increased by 1, y increased from 0 to 2. So y increased by 2. So for this portion, the slope is 2, okay? The slope is 2. Then how can I describe that? So because the slope is 2, I'm gonna multiply this number to the entire portion inside of the absolute value. So be careful, this is not gonna be y is absolute value of 2x plus 1. Instead, it is going to be y is absolute value of 2 times parentheses x plus 1. Okay? The reason is we want to make sure when x is -1, y is 0, right? We want to make sure when x is -1, y is 0. But if I multiply 2 only to x, the function becomes absolute value of 2x plus 1. Then when x is -1, y is -2 plus 1, -1, and absolute value of -1, 1. So y is not 0, right? But if I multiply 2 to the entire part of the absolute value, such as this, absolute value of 2 times x plus 1. Now if x is -1, y is absolute value of 2 times -1 plus 1, which is absolute value of 2 times 0, so 0, which is corresponding to this graph. Okay? So you can just say y is absolute value of 2 times x plus 1, or you can distribute if you want. So you can say y is absolute value of 2x plus 2, first of all. Okay? Then now let's write down this function as a piecewise function. So y is, so this positive portion, okay? This one is where the slope is 2 and the y-intercept is 2. So we just copy this, 2x plus 2. From where to where? From when x is -1 and beyond, right? So x is greater than or equal to -1. Then how about this left portion? Okay, so the left portion, as you can see, x increased by 1 and y decreased by 2. So the slope is -2/1 or -2x, right? But this case, we need to find the y-intercept. Again, we are going to use the same method. I'm going to choose this point where x is -2, y is 2. So again, we can use the point slope form. So y minus y coordinate 2 equals slope times x minus x coordinate. Then y minus 2 is -2 times x plus 2. Y minus 2 is, we distribute, -2x minus 4. And now we add 2 to both sides. Y is -2x minus 2. So we could find out that this left portion, the equation is -2x minus 2. And what? When x is less than -1. So this is the piecewise version of the graph on the top. Okay? So hope this helped, and see you next time.